All right, let's dive in. We're going to talk about the absolute engine room of modern observability, and that's the OpenTelemetry SDKs. These are the magic tools that take all that noisy, chaotic system data and actually turn it into something clear, something valuable. So, if you've ever worked with distributed systems, you definitely know this feeling. A single bug gets reported, right? And suddenly you're on this wild goose chase, hunting it down across dozens, maybe even hundreds of different services. It's like trying to find a needle in a haystack. In a field of haystacks, it's just a nightmare. And here's the real kicker, the core of the whole problem. It's because your data just doesn't speak the same language. You've got your Python service over here describing an error one way, then your Java service says something completely different, and don't even get me started on the Node.js front end, it's speaking its own dialect entirely. It's just total chaos.
Okay, so this inconsistency is the single biggest roadblock to getting any kind of effective observability. I mean, without a common language, how are you supposed to connect the dots? You can't correlate events, you can't trace requests from end to end, you basically can't understand the health of your system as a whole.
But this is where the OpenTelemetry SDK swoops in to save the day. Think of it as your universal translator, your data organizer, and your shipping agent all rolled into one. It's the practical, boots-on-the-ground tool that finally brings some order to all that chaos. Now, this is a super common point of confusion, so let's clear it up. The difference between the API and the SDK. The easiest way to think about it is this. The API is like the blueprint. It just defines what a trace or a metric should even look like. But the SDK, that's the factory. It's the concrete, real-world thing that actually does the work, building the data, processing it, and shipping it out.
Yeah, it really just boils down to this simple idea. The API tells you what to collect, the SDK is how you actually go about collecting it. One is the what, the other is the how. Okay, so we've got a handle on what it is, but how does an SDK actually work? Like, how does it take that raw data from your application and get it all the way over to your analysis tools? Let's follow the journey. So first things first, the SDK is juggling three main types of data, or as we call them, signals. You've got traces, that's the journey a request takes through your system. Then you have metrics, the hard performance numbers like CPU usage or latency. And finally, logs, which give you that crucial context for specific events, like an error message. The cool thing is, the SDK handles all of this. All right, let's trace the full journey of your data. It all starts right in your app's code with calls to the OpenTelemetry API. The SDK picks up those calls and starts generating structured telemetry. And here's a really important part. It can apply sampling, which is a lifesaver so you don't just overwhelm your system with too much data. Then it exports everything using this standard protocol OTLP over to a collector. And that collector then forwards it on to whatever backend tools you're using, like Jaeger or Datadog.
Okay, listen up. Everything we've covered so far is important, for sure. But what we're about to get into, this is the absolute key. This is the thing that unlocks the entire value of OpenTelemetry. Seriously, this is the secret sauce. And that secret sauce, that key, is something called semantic conventions. I want you to think of this as the universal rulebook. It's the Rosetta Stone for all of your telemetry data, the thing that makes everyone speak the same language. So what are they? Well, in short, semantic conventions are just a standard way to name things. It's a dictionary. For example, they say that an HTTP method must always be called http.method. I don't care if it's coming from a Go backend or a JavaScript frontend, it's always the same. And that consistency, well, it's everything.
And check this out. Here's a perfect, concrete example. Instead of one of your services calling it HTTP_method and another one calling it, request type, the convention just says, nope, use http.method. And why does that matter? It means you can search for http.statuscode equals 404 across your entire stack, and boom, you get every single relevant error instantly. No more guesswork.
So what does this actually look like in your code? Well, in Python, you'll start by getting something called a tracer provider. This is basically your entry point for creating and managing traces inside your app.
And then you jump over to Java. And hey, it looks pretty familiar. You get a tracer from your config, and you use it to build and start a new span. You just give it a nice, meaningful name like validate payment, so you know what it's doing.
And it's the same story in Node.js. The pattern just continues. You get a tracer, you start a span. And this is the real beauty of it. While the syntax is a little different for each language, the core concepts, and more importantly, the data that gets created, are all perfectly standardized.
And that's all thanks to the SDK and those semantic conventions we just talked about.
Okay, deep breath. We've set up our SDKs, we're following the rulebook. So what? What's the big payoff? Why did we do all this work? Well, this is where we get to the really good stuff.
And trust me, the payoff is huge. Suddenly, with consistent names, root cause analysis actually becomes simple. Cross-service debugging goes from being a total nightmare to something you can actually do. And because all the vendors build their tools to understand these conventions, you get these incredibly powerful dashboards right out of the box. But here's the biggest one. All this standardized, machine-readable data makes your system ready for the future of AIOps. Now, to get all those amazing benefits, you gotta follow a few best practices. So here's a quick cheat sheet. Always use the OTLP protocol. Keep your spans short and meaningful. Don't trace everything under the sun. Add a ton of attributes for context. And I'm gonna say it again, follow those semantic conventions strictly. Don't make up your own names. Just don't.
And that last point, it really brings us to the future. Because all of this clean, structured, standardized data, it isn't just for us humans to stare at on dashboards. It's the perfect fuel for the next big evolution, AIOps, which is just AI for IT operations. Think about it. When a machine can actually understand your telemetry data because it's so well structured, it can start doing some truly incredible things. We're talking about detecting anomalies a human would never catch, automatically correlating issues across different services, predicting outages before they even happen, and, get this, even triggering auto-remediation to fix problems without anyone ever lifting a finger. So let's wrap this all up in a neat little bow. The API, that just defines the concepts. The SDK, that's the engine that actually generates the data. Semantic conventions, that's the all-important rulebook that makes the data consistent. Exporters send it wherever you want, and OTLP is the future-proof protocol that ties it all together. Look, at the end of the day, when you implement OpenTelemetry SDKs correctly, you're not just making your debugging life easier today, you are literally laying the foundation for the intelligent, self-healing systems of tomorrow.
You know, every single request, every error, every metric, it's all part of a story. Your systems are constantly trying to talk to you, to tell you how they're doing. So the real question is, with tools like these, are you finally ready to listen?